The feedwater pump may be driven by an electric motor or a steam turbine. The steam turbine has the obvious advantage of variable speed control, which can be used to adjust the quantity of water being supplied to the boiler. Of course, the same result can be achieved by applying a variable speed hydraulic drive between an electric motor and the pump. The ability to control the quantity of water being pumped into the boiler is vital for safe boiler operation, and the control system must be able to respond rapidly to changes in water level in the boiler caused by variation in turbine load. One of the most common forms of boiler feedwater control is effected through a modulating feedwater control valve. This valve is usually operated according to signals from the boiler control system. In order to provide finer control at low loads, a small bypass is usually fitted, complete with a control valve. The two valves operate together in response to signals from the boiler water level control system. During startup and at low load, the small control valve is operated. Eventually, as load increases, this valve approaches the full open position, and the large valve takes over the operation. A further bypass may be fitted around both of these valves for use in case of failure of the boiler control system or valve actuators. This manual bypass is usually operated by a remotely controlled motor actuator. With the arrangement shown here, a potential problem could arise during normal operation if both control valves were to close, perhaps due to a high water level in the boiler drum. In this case, there would be zero flow of water through the feedwater pump. And as the pump is continuing to rotate, the temperature of the water would rapidly increase and start flashing into steam. This could cause considerable damage to the pump internals. In order to prevent this problem, a recirculating line is fitted to the pump discharge. In the event that the feedwater flow through the pump falls below a preset minimum, the recirculating valve opens automatically and passes water directly back to the de-aerator, thus maintaining the pump in a safe operating condition. In many power plants, two boiler feedwater pumps may be installed, providing 100% standby. An alternative to this arrangement is to provide three 50% pumps. The standby pump may be made available for automatic start in case of failure of the running pump and a decrease in feedwater pressure. The feedwater pump is truly the heart of the power plant cycle and therefore must provide 100% reliability in supplying high-pressure feedwater. Make sure that you're familiar with all the mechanical details of your particular feedwater pumps, and especially the procedures for making the pump available. For example, on the standby pump, you will typically need to make sure that the inlet and outlet isolating valves are open, the pump is fully charged with water, and all air has been vented. The recirculating line isolating valves are open. The recirculating line control valves should be open, as there is no flow passing through this standby pump. Sealing water is being supplied to the glands. Cooling water is being supplied to the bearings and the lube oil cooler. The forced lubrication system must be available for service with the correct amount of lube oil in the tank. The balance piston leak-off line must be open if installed. The purpose of this line is to help balance the axial thrust of the pump impeller. And the driving motor must be ready for operation with the breaker racked in and power available. Your particular pumps may have other requirements. Make sure that you're familiar with all of these procedures. As well as providing feedwater for the boiler, the feedwater system provides water for the de-superheaters, that is, on the main steam and reheat systems. De-superheating water is tapped off the feedwater system at a point fairly close to the feedwater pump. The reason for this is as follows. A sufficiently high pressure must be available in order to force the de-superheating water into the steam systems. The temperature of the water should be such as to provide cooling action. Therefore, it should be taken before feed water passes through the high-pressure feed water heater.